So today we're going to translate exponential growth and decay functions. So an exponential growth would get bigger on the right-hand side. It gets bigger on the right-hand side. So I know this is a growth, this is a growth. Down here, these are also growths. I can see they're bigger on the right-hand side. So exponential growths all have a base. So here's 2, the base is 2, here's 3, and here's 4. To count the base value, you're going to count the y distance from the asymptote. And y'all, the asymptote is right here. So it's the y distance from the asymptote. So if you look here, how many do I count up from the y? I count up 2. Here, if this is my asymptote, I would count up 1, 2, 3. And here, I would count up 1, 2, 3, 1, 2, 3, 4. And so the base is 4. So we're going to count the y distance from the asymptote. Also, the exponential growth and decay are both going to go through this point right here. And the reason for that is x equals 0. Anything to the 0 power equals 1. Anything to the 0 power equals 1. Anything to the 0 power equals 1. So I'm going to call this, we don't have a vertex, it's our 1, it's the y-intercept, and that's the that is the point that I'm going to shift back and forth. So, first of all, here is my asymptote. And the asymptote is always y equals 0. It's always y equals 0. So, when the asymptote is at y equals 0, my k is y equals 0. So next, does this go through, does it go through here? It does not. So right here is where it's 1 off. How many did I shift from here to here? I shifted 3 to the right. So this is my 3. And it's negative because it went to the right. And my b, we're going to count. Here's the asymptote. So how many from the asymptote to touch? 2. So when I write this, my horizontal asymptote is at y equals 0. My function is going to be 2 to the x minus 3. I'm going to go to the next one. My asymptote is at y equals 0. My function, so first of all, here is off 1. So I moved this way 4. It's a liar, right? So it's not negative 4, it's positive 4. And then I want to count the distance from after this one, 1, 2, 3. So my base is 3. So I'm going to have 3 to the x minus or plus 4. Okay, so on this one, it's going to be our translation up and down, and the horizontal asymptote is going to control that. And so now my horizontal asymptote is at y equals negative 5, which is going to make my k negative 5. So my 1 is right here on 0. It hasn't shifted off the axis. And so I'm going to count from here, 1, 2, 3. so my b is 3. So I'm going to have f of x equals 3 to the x, we didn't shift it left or right, and then minus 5. So the horizontal asymptote is right here. So the horizontal asymptote is at y equals 1, and that's going to make your k value 1. I am 1 right here, and that shifted 1, 2, 3 to the right, so I know that my h is negative 3. And now I'm going to go over 1 from the 1 point and count 1, 2. So my base is 2. So my function is going to be 2 to the x minus 3 plus 1. So my domain from left to right is negative infinity to infinity, and my range is going to be from the asymptote up, and so that is going to be from 1 to infinity. Okay. So it looks like the printing's off a little bit. We're not going to be able to do the next one. So number 4, let's go ahead and let's find our horizontal asymptote is at negative 5. It is off 1. It is off the asymptote 1 at negative 1. So that is a liar. So my h is 1. My k is negative 5. And from here, I'm going to go over 1 and count. 1, 2, 3, 4. So my base is 4. So my function is going to be 4 to the x plus 1 minus 5. My range, left to right, is negative infinity to infinity. Domain, and my range is bottom to top. It always uses my k, which is going to be negative 5 to infinity. And notice the negative 5 gets a parenthesis because we can't touch the asymptote. Now, if you look at the next one, this is an example of an exponential decay. And the reason I know it's a decay is it's not getting bigger on the right, it's getting smaller on the right. It's up on this side, and that tells me it's a decay. And the only thing that's going to change is that when it's a decay, we're going to make the b a fraction, 1 over the number we find. So if I look here, here's my asymptote right here. Here is my 1. And if I go over and count up, I still counted 2, but since it's on this side, it's 1/2 instead of 2. The same thing will happen here. Here's my 1. If I count over 1, 2, 3, I get 1/3 here. If I count over 1, 1, 2, 3, 4, I get 1/4. So here, this is up. This tells me it's a decay. Here is my asymptote, and we talked the asymptote is going to give you your horizontal asymptote is y equals 4, which gives me my k value. Now, I have to find my first point, and that shifted 2 to the left. So my x's are liars, so it's going to be a positive 2. I'm going to go back 1, and I'm going to count 1, 2, 3, but that is 1/3. So when I write my function, I'm going to get 1/3 x plus 2 plus 4. My domain is going to be negative infinity to infinity, and my range is going to be 4 to infinity. So the last thing we have to talk about is the exponential reflections. And so here is my parent function for an exponential growth. I know it's a growth because it's up to the right. A reflection over the x-axis is going to be down to the right. This is up to the right. It's pointing down to the right. So that is going to give me my negative in front. The 3 is not negative. it's negative 1 times 3 to the x because this is our reflection. So now, here is my parent function of an exponential decay because it's up to the left, but a negative makes it down to the left. The 1/5 is up to the left. It's still a decay, but this one is a negative because it's down to the left. So let's just start. On this example, this is down on the left. That tells me that my reflection, I'm going to have a negative here. We're going to put it right here because it's going to go in my A value. So here we're going to start the same place, asymptote first, always. So my horizontal asymptote is at y equals -2. The -2 is my k. Next, I have to find the spot that is 1 off the asymptote. It's right here, and it got shifted 4 to the left. It's a liar, so it's going to be a +4. And then I have to find my base. So I'm going to count back and then up. 1, 2, 3. So it's 3, but this is 1/3. And this is a decay. And so this is my negative. So my function is going to be a -1/3 x plus 4 minus 2. So the next one is down on the right, which makes this a decay. That makes this negative. I'm going to go ahead and dot in my asymptote, which is right here. And that makes my horizontal asymptote 3. That's going to make my k 3. So now I have to find my 1, which is here. I'm 2 off, which means it's -2 because it's a liar. And then we have to find the base, and it's a growth. Sorry, I circled the wrong thing here. It's a growth, so it's not a fraction like the decay. So I'm going to count 1, 2, 3, 4. So I get 4. And that's going to make my function -4 to the x minus 2 plus 3. The next one is down to the left, and that's going to make decay. Go ahead and dot in your asymptote. My asymptote is at 6, which makes my k at 6. My A is going to be negative because we're upside down. I'm going to find the 1 point, which is, let's see here. This is my 6. So here's my 1 point right here. And that shifted me 3 to the right, so it's -3. And when I find my base, I'm going to count up 2. It's a decay, so that gives me 1/2. So my function is going to be -1/2 x minus 3 plus 6. This is down to the right, so this is going to be a growth. It's upside down, so it's negative. I'm going to go ahead and dot in my asymptote. It's what I always start with. It's at 3. That makes my k 3. And so here's my 1. So it shifted 4 to the left, which makes this a +4. And my base, I'm going to go up, back 1 and then count 1, 2, 3, 4, 5. So I'm going to get f of x. Let me count again. 1, 2, 3, 4. Yeah, it's 5. F of x equals a -5 x plus 4 plus 3.